Welcome back, everybody. Ready for another deep dive?
Absolutely. Let's do it.
Fantastic. Today, we're heading out to the edge of our solar system, to those fascinating gas giants, Jupiter, Saturn, Uranus, and Neptune.
Yeah, they're pretty incredible.
We've got a whole bunch of articles here focusing on, well, how Hubble has been watching them over time.
Right, through the OPAL program.
Exactly, OPAL. It's basically like turning Hubble into, well, a dedicated weather satellite for these planets.
You know, it's wild to think that it can capture images almost as good as the ones Voyager took decades ago.
Oh, yeah, remember those. Incredible.
But the thing is, Voyager just got those quick snapshots, right? Like a quick tour bus drive-by. Hubble's been staring at these planets for years.
And not only that, it's seeing them in ways we can't from Earth. Hubble sees in ultraviolet and infrared as well as the visible light.
Yeah, it gives us a totally different view. Like having X-ray vision for these planets, we can see things like the composition and temperature of the different layers of their atmospheres.
But it's not just about pretty pictures.
No, not at all. We're getting some serious science out of this. We can track cloud patterns, storms, and just how their atmospheres move over time.
All right, so let's start with the big guy, Jupiter. We all know it's a massive, stormy planet.
Oh yeah, those cloud bands are constantly shifting and changing.
So what has Hubble shown us about Jupiter's, well, wild weather over the past decade?
Well, one of the most interesting things is that we've actually been watching the Great Red Spot shrink.
Oh, wow. Yeah, I remember hearing about that.
It's still huge, of course.
Oh, absolutely. I mean, it can swallow Earth whole, no problem.
Yeah, but it's definitely getting smaller. And here's what's really interesting. The winds inside the storm seem to be getting more intense as it shrinks.
Huh. So is that like a typical thing for storms? To get more intense as they shrink?
That's a great question. We're still trying to figure that out.
Okay, so is that unique to the Great Red Spot then? Or is there something else going on?
Well, think about it this way. The energy in a system has to go somewhere, right? So if a storm contracts, that energy might get concentrated, leading to faster winds.
Ah, okay. I see.
But yeah, it's something scientists are still researching.
Fascinating. So Hubble's also spotted those mysterious dark ovals on Jupiter, the ones you can only see in ultraviolet light.
Oh, right.
What's the latest thinking on what those might be?
Well, the best guess right now is that they're areas where high-altitude haze is absorbing all that ultraviolet light.
Okay, so like a giant atmospheric sunblock.
Yeah, something like that. But they could also be related to something in the atmosphere, like a particular mix of gases or some chemical process we don't fully understand yet.
So another mystery to solve.
Exactly.
All right, so we've got all this great data from Hubble, right? But how does that compare to what we can learn from telescopes here on Earth?
Well, Hubble has a big advantage. It's not hampered by all the stuff that gets in the way down here, like the atmosphere.
Oh, right, like all that distortion and light pollution and everything.
Exactly. And Hubble doesn't have to deal with, well, daytime. It can just stare at Jupiter for hours on end.
So we get a much clearer picture of what's going on.
Oh, absolutely. We can really see the whole dynamic weather system in action.
Okay, so let's move on from constantly stormy Jupiter to, well, Saturn. The rained wonder.
Yeah, Saturn is something else.
And it's got a much more noticeable tilt than Jupiter does, which means more dramatic seasonal changes.
Oh, yeah, for sure.
And so where are we at with observing Saturn seasons? Have we seen much change?
Well, Saturn takes 29 years to go around the sun, so we've only captured a small piece of a Saturnian year with Hubble.
Okay, right, of course. So we've got to be patient.
We do. But even in that short time, we've seen some pretty interesting changes in the color of Saturn's atmosphere.
Huh. Color changes, really.
Yeah, and they seem to be tied to the changing seasons.
Okay, so is that just from shifting cloud patterns, or could it be something more complex?
It's probably a mix of things. The angle of sunlight changes, as Saturn goes around the sun, and then there's the height of the clouds, and even changes in the makeup of the atmosphere itself.
Wow. Okay, so lots of factors.
Oh, yeah. And Hubble helps us untangle all that by looking at Saturn in different wavelengths of light.
Okay, so that lets us sort of see through the different layers.
Exactly.
All right, and what about those mysterious spokes in Saturn's rings? They seem to come and go with the seasons, but we still don't really know why.
Yeah, those spokes are a real head-scratcher.
What's the leading theory right now?
Well, one of the main ideas is that they're connected to Saturn's crazy strong magnetic field.
Oh, right. I forgot about that.
Yeah, it's incredibly powerful. And the thinking is that this magnetic field is interacting with charged particles in the rings somehow.
Okay, so it's a magnetic phenomena.
It seems that way. And Hubble's been watching long enough that we can kind of predict when the spokes will appear.
Wow, so we're starting to figure it out.
We are, but we still don't know exactly how they form and disappear. So lots more to learn.
Incredible. It's amazing how much we still don't know.
I know, right? Even in our own solar system.
It's just crazy,
Yeah.
to think about those forces at work on Saturn.
Yeah, it's wild. And, all this isn't just about learning about these distant planets, right? It's helping us understand basic stuff about weather and climate.
Yeah.
I mean, here on Earth, too, and on planets around other stars.
You mentioned that earlier, how the physics of weather is like universal, whether it's a hurricane here or a giant storm on Jupiter. Could you unpack that a little more?
Oh, absolutely. The basic principles, they're the same everywhere. It's all about how heat and pressure interact, and then you throw in rotation and what the atmosphere is made of. And by studying those processes on a giant scale, like we see on Jupiter or Saturn, it helps us really understand how they work in general.
So it's like having these giant labs out in space,
Right.
where we can watch these incredible weather events unfold.
Exactly. And what we learn there can help us back here on Earth. We can improve our climate models, maybe even get better at predicting extreme weather.
So it's not just about learning about other planets, it's about understanding our own better.
Yeah, exactly. And it goes even further than that. What we learn from these gas giants, it can help us understand exoplanets too. Those planets around other stars.
Right, we've discovered thousands of them, but we can't really see them directly.
Nope, most of what we know is just their size and their orbit. We have to use other methods to study their atmospheres.
And this is where our understanding of the gas giants comes in handy, right?
Absolutely. By looking at the light that passes through an exoplanet's atmosphere, we can try to find molecules and elements that we know exist on Jupiter and Saturn and those guys.
So it's like our solar system is the key, to understanding these far-off worlds.
Yeah, I like that. A Rosetta Stone for exoplanets. What we learn here, we can apply it out there.
So what kinds of things are we trying to learn about these exoplanets then by, applying all this knowledge?
We're looking for clues about what they're made of. Their temperature, how much pressure there is, if there are clouds, or maybe even storms. And by comparing them to our own gas giants, we can start to classify them, and figure out if they could possibly support life.
Okay, I want to go back to something we talked about earlier, the great red spot on Jupiter. We've been watching it shrink for a while now.
Yeah.
What are the main theories about why that's happening?
Well, that's one of the big mysteries, One idea is that these smaller storms, like little eddies, are merging with it.
Oh, I see.
And that could be disrupting the flow and causing it to kind of contract.
Okay.
Another idea is that the jet streams around it are changing, and that could be messing with its stability.
So is there a chance it could, disappear completely one day?
It's definitely possible.
Yeah.
But, it's tough to predict what's going to happen with something as complicated as that. It's been raging for centuries at least.
Right.
And who knows, it could keep changing in ways we haven't even thought of yet.
So we're just watching this massive planetary event unfold in front of us. And it's happening on a timescale we can barely grasp.
I know. It's incredible. It really makes you appreciate the vastness of everything out there and, all those forces at play, even just in our own little corner of the universe.
Let's jump over to Saturn now and talk more about those spokes in its rings. We touch on them a bit, but I'm, really fascinated by them.
Yeah, they're one of those things that remind you we still have so much to learn.
For sure.
They're these dark streaks, like radial streaks, and they rotate with the rings.
And they just pop in and out.
Yeah, over hours or even days.
So we think it's got something to do with Saturn's magnetic field, right?
Right. Saturn's magnetic field is crazy strong, off the charts. And the thinking is that it interacts with the charged particles in the rings and somehow creates those temporary structures.
But how does that even work? I mean, how does a magnetic field make visible patterns in a ring system made of ice and rock?
That's the mystery, isn't it? We don't really know how the magnetic field interacts with each of those tiny particles, or how they clump together, and then, how the spokes form and then disappear.
Okay, so more research to be done.
Lots more. It shows that even something as familiar as Saturn's rings can still hold these really big secrets.
Well, from the rings of Saturn, we're going to travel even farther out to the ice giants.
Mm-hmm.
And we'll start with Uranus, the planet that's tilted on its side.
Yeah, Uranus is a total oddball.
And it means that its seasons are, crazy different from ours.
Oh, yeah. Imagine one pole being bathed in sunlight for 42 years, and the other one is in total darkness.
Wow, 42 years. That's like most of a human lifetime.
It is. It's mind-blowing.
So what's Hubble seen as Uranus's northern hemisphere is coming out of, like, decades of winter darkness?
Some really interesting things, actually. The polar region, which used to be in shadow, it's been getting a lot brighter as it gets more sunlight.
Okay, makes sense.
And we're also seeing more storms as the atmosphere heats up. It's like the planet is waking up after a long nap.
So it's going from a quiet, icy place to a more, I don't know, lively, energetic one.
Yeah, exactly. And Hubble's giving us this amazing detailed view of this whole planetary transformation.
So what about Uranus's rings? Are they as, spectacular as Saturn's?
Not quite as showy. Uranus's rings, they're fainter and thinner, and that makes them really hard to see from Earth.
Oh, I didn't realize that.
Yeah, they weren't even discovered until 1977.
Oh, wow, really?
Astronomers saw this, like, slight dimming of starlight as Uranus passed in front of a distant star. That's how we found them.
So it was total luck, like a cosmic coincidence.
Pretty much. But since then, Hubble has given us much better views. We can see their structure, what they're made of, that kind of thing.
And they're mostly ice, right?
Yeah, just like Saturn's. But
Right.
they're smaller, and there are fewer of them.
Okay, so from the topsy-turvy world of Uranus, we come to our last stop, Neptune.
Mm-hmm.
The outermost giant planet.
Neptune. Always keeping it interesting.
So Neptune may be the farthest out, but it's certainly not boring.
Oh, no, not at all.
It's got some of the fiercest winds in the solar system, these crazy storms, and, get this, seasons that last for decades.
Oh, yeah. Neptune likes to take its time.
And one of the coolest things that Hubble has found is that Neptune's weather is actually connected to the sun's activity, which seems weird, considering how far away it is.
You'd think, right, that a planet billions of miles away wouldn't be affected that much by what the sun is doing.
Exactly.
But Hubble shows us, nope, there's a definite connection.
So how does that work? How can the sun's activity mess with the weather on a planet that far away?
We're still working on that one.
Okay.
But one idea is that changes in the sun's radiation can affect the temperature and, well, the circulation patterns in Neptune's atmosphere.
Okay. And even small changes in temperature, they can make a big difference, right?
Oh, yeah, for sure. They can affect cloud formation, wind speeds, even the formation of those dark spots.
Speaking of those dark spots, they're another puzzle, right? They seem to appear and disappear much faster than Jupiter's Great Red Spot. What makes them so different?
That's a great question. It probably has something to do with the way Neptune's atmosphere works. It's complex. There's lots of stuff going on.
And didn't you say earlier that each season on Neptune is like 40 years long?
Yeah, it's crazy, right?
So we've only been able to watch a tiny part of Neptune's year.
That's right. So who knows what else we'll find? There's still so much to discover.
It's mind-boggling, honestly, the scale of it all,
Yeah.
the complexity. And we're only talking about these 4 planets.
I know. It really puts things into perspective, doesn't it? Makes you realize how much we don't know and how much more there is out there.
It really is amazing to think about, even right here in our own solar system. There's still so many things we don't know.
Oh, absolutely. And like we've been talking about, these mysteries, they're not just about understanding these planets themselves, right? They help us understand things like Earth's climate and maybe even finding life on other planets.
And just the fundamental physics of the universe.
Exactly.
You mentioned earlier how Hubble's observations are helping us understand those exoplanets, those orbiting other stars.
Yeah.
Can you talk a bit more about that? Like, how does studying those giant planets in our solar system help us understand these distant worlds that we can't even see directly?
Well, it's all about, using what we already know to try and figure out the stuff we don't know. We've learned a ton about the atmospheres of Jupiter and Saturn and those guys, like what they're made of, their temperatures, how the clouds form, all that stuff.
So we're using that information as a starting point, like a comparison.
Exactly. When we look at the light passing through an exoplanet's atmosphere, we can try to find molecules and elements that we know are on our own gas giants.
Oh, okay.
And that can tell us things about the exoplanet's temperature, the pressure, and maybe even if it could support life.
So it's like we've got this blueprint, right? These examples that we can use to decode the atmospheres of these, alien worlds.
That's a great way to put it. And as we get more data about exoplanets and as we learn more about our own gas giants, we'll get better and better at understanding those signals.
So we're at the point where we can actually start to figure out the atmospheres of planets that are light years away.
We are. It's a really exciting time.
What are the main things we're hoping to learn about exoplanets by, using all this knowledge?
Well, ultimately, we're looking for signs of life, right?
Big question.
The big one. And one of the things that might tell us there's life, as we know it, is the presence of certain molecules in the atmosphere. Things like oxygen, methane, water vapor.
Right, the building block.
Exactly. And by looking at the light that passes through their atmospheres, we can search for those signs.
So by studying the planets we know, we might just find evidence of life on another planet. That would be amazing.
It would be incredible. And it really shows how important it is to keep exploring and keep observing, both in our own solar system and beyond. The more we learn about all these different planets and atmospheres, the better chance we have of finding life somewhere else.
Well, we've covered a lot of ground in this deep dive.
Yeah.
Shrinking storms, mysterious rings, and even those distant exoplanets. What do you think is the biggest takeaway from Hubble's, decade of watching these outer planets?
For me, it's realizing that these planets are way more dynamic and complex than we ever thought. They're not just sitting there unchanging.
No,
They're constantly evolving. Their atmospheres are always in motion. And it's all driven by things we're only just starting to understand.
And like we've talked about, this isn't just about those planets. It's about planetary science in general.
Oh, absolutely. What we've learned from Hubble, it's changing how we think about how planets form, how their atmospheres work, and, of course, the search for life beyond Earth.
So what's next? What are the big questions we still have about those outer planets, and how can we answer them?
Well, we've touched on a bunch of them already. The shrinking of Jupiter's Great Red Spot, those spokes in Saturn's rings, the weird seasons on Uranus and Neptune, and how Neptune's weather seems connected to what the sun's doing.
So many questions. And it seems like every time we find an answer, it just leads to more questions.
That's science for you. But the good news is that we've got new telescopes coming online, both on the ground and in space. And they'll give us even more powerful ways to observe these planets.
Like the James Webb Space Telescope. I've heard that one can see even deeper into those atmospheres than Hubble can.
Yeah, it can. And there are these huge telescopes being built on Earth that will have incredible resolution. So we'll be able to see even more detail and track those changes over time, even better than we can now.
So we're on the edge of a whole new era of discovery.
We are.
Wow, that's exciting.
I know. And it really makes you think, what else is out there in our own solar system that we haven't even imagined yet? Just waiting to be discovered.
A great question to leave our listeners with. Thanks for joining us on this deep dive into the outer solar system. Until next time, keep looking up.